Good morning, student. Today chemistry class for class 12 lesson name is a solution. So previous class continue. Previous class, that is the previous video class, that is the video part 3. Dealing with problems and MCQ questions, solution lesson. Particularly MCQ question based on concentration of solution and problem. Now, this today topic is solubility of gas in liquid. Solubility of gas in liquid. This topic is very important. Gas dissolved in liquid. Gas dissolved in liquid is today we will discuss about the topic under Henry laws and derivations is there. Solubility of gas in a liquid. There is a gas dissolved in liquid. We hope you study very well and you see the videos and you refer the textbook and take a notes also. Now this is topic solubility of gas in liquid. You know, gases dissolve in liquid by using the pressures. Gas dissolve in liquid to form homogeneous solution. Homogeneous solution. Say example, you take a one beaker. This is ordinary distilled water or ordinary water. This ordinary water containing dissolved oxygen. This ordinary water containing dissolved oxygen. Here, what is the gas? Oxygen gas is present. Already, oxygen dissolved oxygen gas. That is gases. Here, oxygen gas dissolved in water. Dissolved in water. That is a liquid. Dissolved in liquid to form homogeneous solution. This is the homogeneous, not heterogeneous. Only one phase. This gas solution, that is a one phase. So it is known as homogeneous solution. This is known as homogeneous solution. That is known as solubility of gas. Say example, a great example. Soda water. You know, you're drinking soda water. Drinking soda water, Pepsi, Coca-Cola and Sprite. That soda water or flavored aerated drinks containing carbon dioxide is dissolved in water. Carbon dioxide gas is present. There is a carbon dioxide gas dissolved in water. This is a great example. Soda water. Soda water contains carbon dioxide gas dissolved in water. Carbon dioxide gas dissolved in water is known as soda water. Soda water is a great example. Okay, that's all gas dissolved in water. Now, solubility, definition of solubility. Okay, solubility, definition of solubility of gas. You got volume of the gas in centimeter cube will dissolve in 1 centimeter of the liquid. That is, take a one beaker, you fill it with water. This is a liquid, water liquid. Volume of the gas in centimeter cube, that is 1 centimeter cube dissolved in 1 centimeter cube water. Dissolved in 1 centimeter of liquid to form saturated solution. This is a saturated solution. Constant particular temperature and pressure. Here temperature is a very important role. Particular temperature. Temperature is a constant. Particularly constant. Particular amount of gas, that is a 1 centimeter cube of gas dissolved in 1 centimeter cube of solvent, that is a liquid, to form saturated solution. This is a previous class I explained saturated solution and unsaturated solution and supersaturated solution. Here saturated solution is formed by passing gas through the solution at a particular temperature and pressure is known as solubility. That is known as solubility. That is known as solubility. Okay, this is solubility. Now, the solubility of gas affecting following factor. That is a following factor. Solubility of gas is determined by following factor. In a factor, which factor affect the solubility or decide the solubility, whether the gas dissolved maximum amount or minimum amount or is not dissolved. So this is the following factors. 3 factors is there. First factor, nature of the gas and solvent. This solvent nature, this gas nature. Second, effect of temperature. If a temperature increasing or decreasing, solubility nature may be increasing or decreasing. We will discuss about this. Third factor, effect of pressure. If your pressure increasing, solubility increasing or decreasing. We will see the three factors. Particularly effect of factor, effect of pressure is a very important topic. Okay, now student, we will listen first. Nature of the gas and solvent. Some gases maximum dissolve in water. Some gases less amount of dissolve in water. Less amount. Say less soluble in water. Less soluble in water. Gases less soluble in water. Which gas is less soluble in water? Oxygen. Very trace amount is present. This gas is dissolved in water, is responsible for aquatic animal life. Very trace amount is dissolved. Very less amount. Then next nitrogen. Next helium and argon. These four gases, etc. Mainly these four gases: oxygen, nitrogen, helium, argon. That is noble gases, and oxygen, nitrogen is less soluble in water. These gases are less soluble in water. That is a solvent. Here, what is the solvent? Water. Yes, solvent. Solid. What is the solid? Gas. Dissolved in water. That is the oxygen, nitrogen, helium, argon. This is less solubility. This is a less solubility. Now, gases. It is a more soluble in water. Maximum amount. That is, what is the gas? Sulfur dioxide, ammonia, and hydrogen chloride. Hydrogen chloride gas, not acid. This is the gas. Sulfur dioxide gas, ammonia gas, and hydrogen chloride gas is a more soluble in water. This gas is a more soluble, maximum amount dissolved in water. So here already some gases less soluble in water, some gases more soluble in water. So gas, nature of the gas determine solubility. Okay. Now second factors affecting solubility, determine solubility. Effect of temperature. Now it's a very interesting topic. Now, if your temperature increasing, solubility decreasing. Temperature increasing and solubility is decreasing. Temperature decreasing, solubility increasing. This is very important. And vice versa. Temperature increasing, solubility decreasing. Temperature increasing. If it is temperature decreasing, the solubility of gas is decreasing. Temperature decreasing, solubility of gas is increasing. Okay. Now you see how we will prove this. Dissolution of gas in solvent. That is a gas dissolved in solvent. Gas dissolved in solvent. Say example. You take your beaker, you fill it with water. This is a solvent. What is a solvent? Water is a solvent. What is a solvent? Now, you pass sulfur trioxide gas. So this is a gas dissolving in water. That is a solvent. It is known as dissolution. This process is known as dissolution. When sulfur dioxide passing through the or dissolving in water, is lot of heat is released. So this is known as exothermic reaction, exothermic process. So dissolution of gas in solvent is known as exothermic. That is means gas dissolved in solvent to form solution, heat is releasing. So exothermic reaction. exothermic reaction means temperature is decreasing. Temperature decreasing as per Reich-Atelier principle. You study in the 11th standard chemical equilibrium lessons. That is exothermic process. Temperature decreasing, solubility increasing. So in this system, temperature decreasing, solubility maximum dissolve. That is a sulfur dioxide maximum dissolve in water. So here what is the role? Very important role. Temperature, solubility is very important. That is a maximum dissolve very less amount of heat. You know, seawater. That is a sea. The seawater containing dissolved oxygen. This is known as oxygen. Dissolved oxygen is present in a seawater. That is a seawater containing dissolved oxygen. Seawater containing dissolved oxygen. Dissolving oxygen. When summer season. When summer season, that is a lot of heat. What temperature increasing? So maximum sunlight. So in the summer season, or global warming, or summer season, maximum amount of heat is found. So temperature increasing, solubility decreasing. What happened? This dissolved oxygen is escaping from seawater. So amount of oxygen is less in seawater. So it is a problem for aquatic animals. It is a problem for aquatic animals. So temperature increasing, solubility decreasing, temperature decreasing, solubility increasing. This is the effect of temperature on solubility. So temperature increasing, the solubility of gas decreasing, temperature decreasing, the solubility of gas increasing. This is the one. Now third, effect of pressure is very important. Third factor, the effect of pressure. Effect of pressure. You know, one activity is that you take care two vessels. This is a water or solvent. This is a piston. Okay. Here is gas piston. Any gas. Okay. Now same gas presence, but here the weight is there. In this piston, that is the weight. What happened? This pressure increasing by applying weight. The gas molecule dissolved maximum amount. So some molecules dissolve when high pressure increasing. Pressure increasing. Here no pressure. Here no pressure. Here pressure increasing. What happened? How do you pressure increasing? You put in a weight on the piston. So what happens? The gas particles dissolved in solvent. Gas particle dissolved in solvent. The gas particle dissolved in solvent. So when pressure increasing, the solubility of the gas increasing. Solubility of the gas increasing. That is the effect of pressure. Here is very important. In this effect of pressure, here Henry law is there. Henry law. That is quantitative relationship between solid of gas and pressure. Is not a law. So quantitative relationship between quantitative, how much amount of gas dissolved in solvent, how much amount of gas dissolved in solvent, that is a quantitative relationship between what is the relationship where solubility and pressure relationship. The relation between solubility and pressure, the Henry law dealing. Henry law is dealing with what? Solubility and pressure. Okay? So Henry law. If M is the mass of the gas, dissolved by unit volume of the solvent and pressure of the gas at equilibrium. If the solution is P. So, what is the law? M is the mass of the gas. Here, mass, that is a gas mass. Mass of the gas dissolved by particular unit volume of the solvent, and the pressure of the gas at equilibrium with the solution is P. Pressure is the P. That is mass directly proportional to the pressure of the gas. So now pressure increasing, mass also dissolving of the gas mass is increasing. So mass and pressure directly proportional to each other. So pressure increasing, solubility of the gas, that is increasing. Now proportionally constant M is equal to Kp. M is equal to Kp. That is K proportionality constant. K is a proportionality constant. Now I will give the graph. Mass graph. Y is equal to this equation. Y is equal to mx plus C form. That is a straight line equation. Y is equal to mx plus C equal to 0. Mx plus 0 is equal to 0. So I will get graph. What is this? Y axis is the M, mass of the gas dissolved. X axis is the pressure. X axis is the pressure. Now here one straight line that is passed through the origin. This is a 0. Intercept, that is a C. Y is equal to mx plus C. That is intercept is a 0. Slope, that is a slope value is equal to K. Slope value is a proportionality constant. You find it. This is Henry law. Okay. Another graph is there. This graph is applicable to entrance examinations. Okay. That is this is a P. That is a helium gas. nitrogen, then oxygen, then oxygen. Okay, this is the same graph. Helium, very less solubility, maximum high pressure solubility very less solubility. Then nitrogen. Low pressure oxygen is a maximum solubility. Low pressure oxygen is a maximum solubility. Low pressure oxygen maximum dissolvability. Then among these three gases, helium very least solubility. So among these gases, solubility, which is the solubility high, oxygen, then nitrogen, next helium. Among this graph, okay. So next, Henry laws in the form of mole fraction. Henry law in the form of mole fraction. In the form of mole fraction. So Henry law in the form of mole fractions. Okay. First, write down for definition. The partial pressure of the gas. Here, partial pressure of the gas in vapor phase that is pressure, what is the value Q, is proportional to the mole fraction of the gas, to the mole fraction of the gas. Mole fraction of the gas, that is pressure directly proportional to the mole fraction. Psi. That is a psi is mole fraction. Previous class I explained concentration of the solution. That is a mole fraction. Partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas. Mole fraction of the gas. Mole fraction of the gas. So pressure is directly proportional to the mole fraction of the gas. Mole fraction of the gas. Now we will change this in the form. Pressure, partial pressure is equal to proportionally constant and mole fraction psi. And mole fraction psi. Here KH is here Henry constant. KH is equal to Henry's constant. Henry's constant. KH is Henry constant. P partial pressure. Partial pressure of the gas. Partial pressure of the gas. X is mole fraction of the gas. Guide, that is not X, it is a guide. Mole fraction of the gas. Mole fraction of the gas. This is Henry law. So partial pressure of the gas is dissolved in water. That is a gas dissolved in water. That is gas partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas. Is proportional to the mole fraction. What is the mole fraction? Psi. That is the P equal to KH into psi. Here KH is a proportionality constant that is known as Henry's constant. This is known as Henry's constant. Now Henry constant values of gases is the signification of Henry constant. Henry constant. Henry constant. Gas. Now temperature. Henry constant. Henry constant. Okay. First gas. So many gases is there. Helium. Temperature, what is it? 293 Kelvin. Henry constant unit, what is the unit? Kilo, Kelvin and bar. Kelvin and bar. Henry constant unit, Kelvin and temperature bar. 144.97. Second gas, hydrogen, 293 Kelvin, 69.16. Now gas 3, nitrogen, 293 Kelvin, 76.48. 76.48. Now nitrogen, temperature increasing, 10 degree increasing, 303, Henry constant 88.48. 88.84. 4. That is the fourth gas, oxygen. 293 Kelvin, Henry constant 34.86. And 303 degree Kelvin, what is the value? 46.8. 46.8. And then next argon gas. And fifth, argon, what's the temperature? 293 Kelvin, Henry constant 40.3. Henry constant 40.3. Then next, carbon dioxide, 293 Kelvin, 1.67. 1.67. And seventh, formaldehyde. That is formaldehyde, 293 Kelvin, 0.413. 0.413. And vinyl chloride, 293 Kelvin, 0.611. And methane, that is a CH4, 293 Kelvin, 0.413. Formaldehyde, 1.83 into 10 power minus 3. Okay, now you see this very important topic. This is a Henry constant. What is the formula for Henry law? Partial pressure is equal to Henry constant and what? Mole fraction of the gas. Mole fraction of the gas. Now wait, this is a Henry constant. Henry constant is related to solubility. You see, gas temperature, Henry constant. We take Kelvin bar. So first gas helium. What is the value of Henry constant? It's a high value, 144.97. Hydrogen gas, 69.16. Nitrogen gas, 293 Kelvin, 76.48. Nitrogen and temperature is increasing. 293, 10 degree increasing. That is a 303. Henry constant increasing. Henry constant increasing. Oxygen also 293 Kelvin, minimum KH value, that is a 34.86. Now temperature increasing 10 degree, 46.82. Argon 40.3. Carbon dioxide 1.67. Formaldehyde is very less, 1.83 10 to the minus 8. Vinyl chloride 0.611. Methane 0.43. 0.413. Now, okay, this is a Henry constant value. What is the relationship between Henry constant and solubility? That is the signification of Henry constant. Signification of Henry constant. Okay, now you see the partial pressure is equal to Henry constant into mole fraction. So we related the Henry constant mole fractions. Related the mole fraction and Henry constant. So mole fraction equal to 1 by Henry constant, or Henry constant is equal to 1 by mole fraction. That is a mole fraction, number of gas is present in solution. How much amount of gas dissolved in solution is a mole fraction. Okay, now you see the equations. Formula: Henry constant, mole fraction decreasing. Mole fraction decreasing. That is the solubility decreasing. Henry constant increasing. When mole fraction decreasing, Henry constant increasing. So Henry constant very lowest, highest value, minimum solubility. Henry constant. Now Henry constant, mole fraction. That is Henry constant decreasing, mole fraction increasing. So solubility, when solubility increasing, Henry constant decreasing, mole fraction increasing, that is solubility increasing. Solubility increasing, mole constant decreasing, that is Henry constant decreasing. Decreasing, mole fraction increasing, that is a solubility increasing. Here very least Henry constant, which is the least Henry constant, formaldehyde. That is a formaldehyde. Formaldehyde is a maximum solubility in gas. Maximum. That is a formaldehyde is a maximum dissolved in water. Maximum dissolved in water is a, because Henry constant very low. Then next, what is the next? 0.5 methane and vinyl chloride, carbon dioxide, carbon dioxide maximum dissolved, because Henry constant is a very low. Henry constant is a very low. This is the relation between the Henry constant and mole fraction. That is means Henry constant solubility relationship. When Henry constant decreasing, solubility increasing. Henry constant decreasing, solubility increasing. That's all. Okay. This topic is over. Next, application of Henry constant. Application of Henry constant. It's a lot of application. A few applications I will write. I will explain application of Henry constant. Application of Henry constant. Application of Henry's law. First application, it's a very interesting application. Do you know soda water? Do you know soda water? Pepsi, Coke, Sprite. That is the carbon dioxide dissolved in water. And which pressure? High pressure or low pressure? That is a closed vessels. That is a high pressure. That is the first application. Increase the solubility of carbon dioxide in soft drinks. In soft drinks, the bottle is sealed under high pressure. The bottle is sealed under high pressure. Under high pressure. That is a soda water. That is any aerobic drinks water is closed. Because high pressure. Carbon dioxide is a pressure. When it is open, the pressure is decreasing. What happens? The dissolved carbon dioxide is escaping. That is the effervescence is formed. Okay, so increasing solubility of carbon dioxide in soft drinks, the bottle is sealed under high pressure. Under high pressure. Okay, this is first applications. So this Henry law applied in a soda water. Henry law applied in a soda water. Second applications in lungs. Henry law is applied. In lungs, Henry law applied. How? Now, hemoglobin is binding with the oxygen. That is, a hemoglobin is binding with the oxygen. What? In the lungs, that is, a lungs is a high pressure. In your lungs, hemoglobin binding with oxygen, high pressure. High pressure. Hemoglobin is binding with oxygen, high pressure. Why? If it is a low pressure, what happens? Easily break. So the organ is not recent. Okay? But in tissues, oxygen delivery. Hemoglobin binding with oxygen is a low pressure. In the tissues, hemoglobin is binding with the oxygen is a low pressure. So what happens if it is low pressure now? And hemoglobin oxygen, the bond is breaking, so easily given to the tissues. But in the lungs, hemoglobin binding with oxygen is a high pressure. So binding with the oxygen is a high pressure. So this is the second application. Now third application. Third application is scuba divers. Scuba divers. Scuba divers. What is the meaning of divers? Scuba divers. That is means in a sea water. In a sea. That is a sea. This is the sea water. Scuba diver means research will take research for our. So in a depth area, the person here. In a depth area, human person containing cylinder is carrying one cylinder carrying respiration process. This cylinder containing air. Air means oxygen. This is hydrogen is a presence. Air containing oxygen. That is a scuba diver. Scuba diver carrying oxygen cylinder. That is a containing oxygen hydrogen. So in a depth area, this is a height. So what happened here in this area? High pressure is a presence. High pressure. What happened when is a pressure increasing? Gas is a dissolved. So what happened in a high pressure? The air containing oxygen and hydrogen. This gas dissolved in blood. This gas is dissolved in blood. So it's a blood containing in a high depth area. Scuba diver containing carrying oxygen cylinder containing oxygen and hydrogen. In a high depth area, the blood dissolved nitrogen gas dissolved in blood. Okay, then what happened? There is a blood vessels. This is the blood vessels. What? Oxygen and nitrogen gas dissolved. When the scuba divers come to the topmost area, this area will come. What happens? This scuba divers now pressure decreasing. Pressure decreasing. Here pressure high. Here pressure decreasing. Depth area pressure high. And the topmost area, surface area pressure is less. This dissolved oxygen and hydrogen, as a particular nitrogen, is released by bubbles. This bubbles is contraction of blood vessels. So this vomiting or even death also is happen. So this phenomena is known as bend. This phenomena is known as bend. So to avoid the bend, the gas is diluted. That is, the air is diluted. This air is diluted by. That is a cylinder containing this air. Cylinder in this cylinder, oxygen cylinder, containing 11.7% helium, 56.2% nitrogen, 32.1% oxygen. So nitrogen is reduced. Nitrogen is maximum 70% is there. Nitrogen 70% is reduced to 56, and then helium gas is added. So amount of nitrogen is reduced. Amount of nitrogen is reduced. Then used for scuba divers. Then used for scuba diver for research purpose. Okay, that's all. Now, very important and fourth application. Entry applicable to high altitude. High altitude. High altitude. High altitude. Hills area. No. This is a Kodaikanal hills. Okay. This is a plain area. The peak, that is a high peak area. High height above the sea level. Here high pressure, here normal pressure, high pressure. But when it is going on this height, the pressure will be reduced. Pressure will be reduced. High altitude. High altitude. So dissolving oxygen in a blood will reduce to form anoxia, vomiting, and also is a form. Okay. This is a high altitude entry law is applicable. Okay. Now this is a entry law. Now next limitation of entry law. Limitation of entry law. Limitation of entry law. Limitation of entry law. First, Henry law is valid only. This is valid only when pressure is low. This law applicable to only low pressure. So high pressure is this law maximum deviation which takes place. Second, temperature is low, very low temperature. Temperature is low. Third, the gas is not highly soluble. It's not highly soluble. Fourth, so this Henry law only applicable to when only pressure is a low pressure and temperature is low and the gas is not highly soluble. So this law is applicable. Okay. Now that's all. This is a solubility of gas in a solution over. Solubility of gas solution is over. Okay. Next class we will discuss about. We will learn about solubility of solid in liquid. Solid in liquids and Raoult law, and we will discuss about next topic ideal solution. So many topics we will discuss and problem also is a discussion. Okay, that's all. Today the class is over.